So, having a continuation from our previous class, we are going to see that sometimes we might be given questions still working with the same stress that we had before and the same strain that we had before, but they will be related as the shear stress or the shear strain due to the type of force being applied, like I said before. Force applied affects. So when it is a shear stress, it is going to affect in our calculations, and also the part of our strain is going to affect our calculation. How are these two going to affect our calculation before we look into the conditions that can happen? Nothing is affected. Nothing is going to change. The stress as it is, we do understand that the stress is equivalent to the force over the area. Only that you are considering to say it's a shear stress. So it is having a special letter to use. This shear stress is represented by the letter tau, our Greek alphabet. That is the only part that we have there, but nothing has changed. Force over area, meaning to say tau is equal to what? The force over the area, the force, the shear force, the type of force that is being applied. So as we used before, as we calculated before, we are going to have a calculation in pascals. And like I said, it will be easier for you to just make conversions to be in megapascal. So the type of force applied is shear force. So there is nothing that has changed. Nothing has changed. The same thing with the shear strain. How were you calculating the strain before? So the shear strain can be represented by the symbol gamma. All right. Remember, you're calculating this using the epsilon, which is given as change in length over the original length. Nothing has changed. It is still the same thing. So the shear strain is going to be the change in length over what? Original length. The distance, the component moved, that is a deflection considered. So this is the distance, the component moved due to the shear. So it is simply considered, can be considered as a deflection. Those are the terms that they'll be just using. Those are the terms that they'll be just using. Original length does not change. The area in meters does not, in square meters. This area in square meters, nothing has changed. We still use those formulas as before. Only that you might be seeing some other terms. So that's talking about this. And also in those calculations, we might see a condition where there is a single shear of parts, where we have a single shear of parts. A single shear of parts, where we have a single shear affected. How does it affect our calculation? It follows that in that case, the area resisting shear force is just one portion, it's just one unit of area that is affecting. So as we do understand that the area is given from what? From pi d squared over 4. It is going to be only one area considered. Only one area considered. That is one area to be considered there. It's a single shear, so it affects your area single. It's going to be area there. Because remember, the area, guys, is going to affect when you're calculating now your shear stress. Remember your tau, shear stress, force over what? Over the area. But the area being calculated as one area there. So as it has affected your area, it also affects your your stress. That's the single stress. And it affects the shear stress because of that area. That's a single shear parts. Okay. Single shear of parts. When it is considered, when they consider that it's a double, they're going to specify that it's a double shear of parts. Like this condition, we've got double shear of parts, two forces considered. All right. So we're going to talk of the double shear of parts. In this case, there are now two sections to be considered. So it doubles the area. So meaning to say the area is going to be 2 times area resisting shearing force. There are now two areas to be considered. So if our area was going to be calculated from pi d squared over 4, what are you going to do? You're simply going to multiply everything by 2. The area is doubled. And from that area that you have calculated, what are you going to do? Definitely calculate your shear stress force over what? Over the area. It is affected also your stress because of the area being multiplied by 2, double. So the single part, nothing is affected. The area just remains as it is. So that is, there's no effect at all. You won't see any effect when it is a single part like that. But when there are two, there are now two areas that are being used, affecting this. All right. Then we also have another part affecting our calculations in this shear, which is called the blanking operation. Okay, so we also consider blanking operation. Operation like that. So in this case, we are going to notice that there is going to be a condition like where the shear force is being applied. Then the surface that we have there has a thickness to be considered. Like this is our blanking. So how is it going to affect our area when it is like this? The area in that case, please be careful, because the area in shear there is a part that is taken, this one, which is being taken. It's being removed from this. They're just trying to show you like that from this surface, there's a portion that is going to be considered, which is in a circular manner. So what is it that we are going to need from that? It is the length, which is referred as the diameter there. With that and the thickness, it is going to give us the area. So it follows that the area can be now given as pi dt, which is pi times the diameter times what? The thickness. Pi dt, that is your area now, times the thickness, where t is the thickness. So t is the thickness, d is the diameter. And from there, you can calculate your shear stress, the shear force over what? Over the area that you calculated here from what? Pi dt. So each and every part that you're given, there must be area to be considered, and you must consider how to calculate that area. So with this, guys, you can answer as many questions considering where shear stress is to be considered. With what we had before, it's only the part of the area that can be affected depending with the layout of the objects that you are given. So we're just gonna consider some of the examples that we are given here. On this question, we are given that a force of 50 kilonewton acts on a bolted plate in Fig 1.20. This is a bolted figure. Thus, we are talking of what? A single shear of force. That is a single shear of parts. There's only one part to be affected. Single shear. There are three. then we talk of what? A double. So meaning say only one area is going to be affected. So what are we given? The force. So according to our information, the force is given 50 kilonewton. Calculate the shear stress. Meaning to say we do not know our tau in that case, the shear stress. In the bolt, which has a diameter of what? 20 millimeters. So we are given the diameter 20 millimeters. Divide this by 1,000, that's 0.02 meters. So this is like the illustration there, trying to show you that it's only one area to be affected. It's a single part that we have there. Okay, so remember, if it is a single shear like that, it is just going to affect our area. Our area is just going to remain as it is. Our area is just going to be pi d squared over 4. That is one area to be considered, as I illustrated before. Only one area. So we can calculate that because we do understand that tau is equal to what? The force over the area. Shear stress. So we need the force. It's there, the area, just going to calculate. You can even just substitute there, or you can calculate your area aside pi times the diameter. That's 0.02 squared over what? Over 4. So this was going to give us our area, as we do understand those values, guys, for area 0.003141596, something like that in square meters. So you can just round off 1, 2, 3, 4. Just going to use 4 there. So my area was going to be 3.14. This was going to change to 2 times 10 to the exponent of minus 4 in what? In square meters. Just write the way that you understand. So with this, we can now calculate our tau, which is our shear stress. Okay, remember your stress, force over area, shear stress. Shear force is given 50 kilonewton, 50 times 10 to the exponent of 3 over the area that you just calculated, 3,142 times 10 to the exponent of minus 4. As we do, and is this still, we are still on the same stress that we had before. As we had it before in megapascal. So just do yourself a favor, multiply this by 10 to the exponent of -6. Your answer is in megapascal. So that's it. So our tau in this case was going to be 159,134. This is what you're going to get on your calculator. That answer automatically is in megapascal. It's nothing else. It's only the section, how it is given. The section. So you must be very careful with each section that you are given. If you consider the second part, they are saying calculate the shear stress in this case. But look at the material. It shows 60 kilonewton acting on a knuckle joint. The diameter of the pin in double shear is in double shear. So there is a double part to be considered because of this. Two forces, okay? Way that is presented there. So to consider being in a double, two areas are to be calculated. This area, there's another area. That is what they're just trying to illustrate. But you just know that once there's a double shear, guys, it affects what? It affects your area. So our area, since we want the stress, our shear stress is going to be what? Force over area. So in actual sense, some textbook, they can just write as force over 2A. Because it's double, they can write it as 2A like that. You calculate your area as usual, then you use the 2 there. Or you can just use it as you are calculating your area. Pi d squared over 4. Multiply that by what? By 2. Automatically. Or use it there. It's one and the same thing, depending with the textbook that you're using. So it's pi times the diameter. As we are given that the diameter of this is 30 millimeters, 0.03 meters. Okay, so you're just going to consider that squared over 4 times 2. So the 2 there is for the double. The double what? The double shear. That is where it is playing a role. The double shear there. it has played a role on the calculation of the area. So meaning to say that our area was going to be 0.001413716669, something like that in square meters, guys, which you can just convert by those movements. Gonna be 1, 2, 3. Let me just try so many values so that at least we can be approximate to the answer. All right, because some of us use that -6. 1, 2, 3, 4, 5, 6. Right? If you want to use -6, it can be somewhere there, which will be 1, 4, 1, 3,7, 1, 7 times 10 to the exponent of -6. You can write your area like that. Or you can use the -4, guys, that you've been using before. Still, that will be one and the same. There will be just a little bit, it's a very, very slight difference on your answers, but that does not affect anything. So the shear stress can be calculated now from what? The force, shear force. Remember, we're given the force applied as our shear is 60 kilonewton. So that is 60 times 10 to the exponent of 3 over what? Area that you just calculate as it is. You write the answer that you calculated, guys. If you used times 10 to the exponent of -3, use that as it is. All right, so that's it. And calculating our stress, our answer to be in megapascal times 10 to the exponent of -6, converting our answer to megapascal. So that was going to give us 42,441 megapascal. Our answer is automatically in megapascal. We've got the stress. So as you can see, it's only the questions will be on the area. The type of the presentation will affect your area, but nothing has changed. Nothing has changed. Force over area. Nothing has changed. Talking of the blanking operation that we had before, remember I presented this before. Said whenever we have got this, it's going to affect also our area. So for a blanking operation, the area is given as what? Pi dt. The area has been affected. So we are given the fig 1.23 shows a blanking operation that needs a force of 30 kilonewton to punch a hole with a diameter of 50 millimeters in steel. With a thickness of 4 millimeters, that is, we are given the thickness, which is in meters, that will be divided by 1,000, 0,004. 1, 2, 3. That will be 0,004. Our thickness. The diameter is given from this part, our diameter 50 millimeters divided by 1,000, 0,05 meters. Determine the shear stress in the plate. Determine the shear stress. As we do understand, force over area. The area, pi dt. So if you are to substitute there, it's fine. You can substitute force over that area, which is pi dt. All that we have been doing here can also be done that way. Instead of you calculating your area here, you can use that here as pi d squared over 4 times 2. So that you do not have a lot of rounded values. You round off this, you can combine on your formula like that, guys. It's in your hands. You're the one who is manipulating this. It's in your hands. So there we can substitute. The force is given. You must operate at what? 30 kilonewton. It must be able to hold that 30 kilonewton over what? Pi times d, our area. Remember, that's pi dt, the diameter, 0,05 times the thickness, 0,004. So from this, we are going to obtain our stress, our shear stress, which is supposed to be in megapascal times 10 to the exponent of -6 in megapascal. So that was going to give us 47,746 megapascal. The moment you multiply by 10 to the exponent of -6, that is automatically giving us that megapascal at the end. So I want you to revise with the type of presentation that you're given. Are you given a blanking operation? Are you given a condition where a double shear is active? Two areas are to be considered. Are you given a condition of a single shear being applied? Only one area has to be calculated. Only one area has to be considered. So these are your typical questions that you might be given. Just make sure you work through with your revisions, your basics. Try to understand each and every part. How does it affect in terms of your calculation? Is it a blanking operation? Is it double? Is it a single? It affects the area. So know your areas and your basics of your calculations from your mathematics. As you can see, guys, these are mathematical calculations thereafter. Knowing your formulas, it's fine, but conversions of units, we are now back to mathematics. So let's try to work with that as much as we can till we meet again.